All right, so in the spirit of continuing with the translations, let's just pick up right here. I have an example that what if I came to you and I said, okay, well, I have a parent function. So I say right to you, I say right here, I say, I have a parent function right here. So I have a radical or square root parent function that I want to transform. So visually in my mind, I'm just pulling that formula, but remember, it doesn't matter whether it's an x squared, x cubed, square root, cube root, whatever it is, absolute value, the a, the h, and the k are going to be in the same spot. So they carry the same value. So I take a look and I say to myself, okay, I want to create an equation that is shifted up 5 times. So can you hit pause here for a moment and create an equation that's shifted up 5 times? All right, so hopefully you're back. You've written your equation on your paper here for a radical. So in this case here, our equation will be y, or you could use f of x either way. This is for number 1. And since we're shifting up, then the a value is not used, so there's no a value, so we just go right to the radical. We're not shifting horizontally. Remember, h is side to side, so there's no h, so I just have, literally, I don't need all of that radical, do I? So I would just have x. But I am shifting up 5 units, so outside the radical, the k value would be plus 5. So that would be if I had to create my own equation, and that equation would be, just to kind of clean it up there so it looks more fluent, f of x is equal to the square root of x plus 5. Make sure that radical is not covering the plus 5. That plus 5 is outside the radical. Okay, so number 2, I want to reflect over the x-axis. So we have 2 new rules down here. You need to add this to your notes, to your reference. Okay, so 2 new rules, and the rules are if you have a reflection over the x-axis, then what happens is, and the one that I want you to remember is probably going to be the most valuable, is going to be this one. And what that's basically saying is it's saying I'm going to take my function and make it negative. This right here is a little more confusing as to what that means, especially on the x-axis reflection. On the y-axis, it makes perfect sense because you can see that you're plugging the negative inside there. But this makes it a little more confusing, so let's stick with this. So right now, based upon what you see right here, based upon the fact that we have a function which is y equals the absolute value of, let me just back up just a little bit, y equals the absolute value of x, absolute value, square root, excuse me. So my question for you is this: if I wanted one that was reflected over the x-axis, do you think that the negative sign would go on the outside or on the inside? So it would be on the outside of the radical or the inside of the radical. And to answer that question, maybe we need to look at the last one, which is reflection about the y-axis. Because on the y-axis, we get y equals the square root of x. And you can see right here what they're saying to you is they're saying that instead of plugging in a positive x now, you're going to plug in a negative x. So we know that our negative sign for this guy is going to go inside. We're actually plugging the negative inside of the function. So that means in this case, for the x-intercept, it would be on the outside. So x-intercept's on the outside, y-intercept's on the inside. So x-intercept is on the outside, y-intercept is on the inside. All right, so that's a quick little look at reflecting over the x-axis and y-axis.